that on all of these questions that we gave you, we only gave you a portion of it, right? And that's because we haven't learned everything that was in this problem yet. Notice also that number 5 is from a BC test. So we're learning these theorems right now in AB calculus, and in about 6 months we're going to take a test on this. And whether you take AB or BC test, this is fair game. So it's a long time to have to remember something. So theorems are often some of the lower scoring questions because it's just slipped out of your mind. So for those of you who are making note cards for things that we're doing right now, keep that stack of note cards and flip through it every now and then. Once a week, once a day, just flip through it. And that way this stuff will be at the forefront of your memory, even if we talked about it a long time ago. Because in AB and BC, we're going to start giving you full questions that involve new stuff, but also still rope in old stuff. So if you keep that in mind, you'll be better prepared. All right, so here we have a graph, and this one was a little bit more conceptual. It says it is continuous, and you can see that, but is this guy differentiable everywhere? No, it is not differentiable everywhere, but it is differentiable on the interval from, say, like 0 to 6, and on the interval from 4 to 2. So this says, is there a value A between -4 and 6, for which the mean value applied to the interval A to 6, so we're finding some random A value and using that interval, that guarantees a C between A and 6, at which f prime of C equals 1/3. So this one's a lot, but if you actually start at the end and work backwards, it's not too bad. F prime of C equaling 1/3 means what? Okay, MVT, yeah. So we're looking for MVT. It also means if we see a derivative equals 1/3, what does that mean? Okay, so prime is actually instantaneous, right? But MVT says there's a place where the instantaneous, so the slope of a tangent line, is equal to the slope of the secant line. So if you look at this, first of all, over here, is the slope over here 1/3 anywhere, instantaneous or otherwise? Well, here it's at 3, 0, there it's at 0, 2, so the slope here is up to over 3, right? The slope here is 2/3. So we ain't getting a 1/3 slope out of this side, which means we restrict our search to over here. The other thing is, if I said my A was over here, then I would have a non-differentiable point in that interval, which means the MVT is thrown out. So there's a couple issues with that. Over here, though, is there any place on this curve where you think the instantaneous rate of change could be 1/3? Maybe somewhere around, yeah, like around 4. And so this is my 1/3 little graph up here. And at 4, yeah, maybe. So the next question is there a place on this graph where, with the interval ending at 6, because that's required of us, is there a place that I could walk back to where the average rate of change would be 1/3? So if we're looking for a slope of 1/3 that has one point right here, I need to go what? Down 1 and to the right 3? Do I have a point there? Down 1 and right 3, 1, 2, 3. Yep. That average rate of change is 1/3, so there's guaranteed to be a value somewhere in between 4 and 6 where we're going to have a instantaneous rate of change of 1/3. That's the mean value theorem. So you kind of work backwards, finding your A first, and then using that and what you know about MVT, differentiability, continuity, and setting the instantaneous rate of change equal to the average rate of change. And you've got that one done. So a little bit of extra thinking, but this part of the question was worth 2 points. So just 2 over here. So finding that A equals 3 was worth 1 point, and then telling why using MVT was your second point. Let me go back because y'all asked about this one. This whole question, all that work, just 2 points. So you can still make a 7 on that without knowing how to do that problem at all. All right, and that was part D, so it was at the very end. So you're like, I've already got 7 points on this. Let's move on. All right, last question. We've got a continuous function, but is this one differentiable everywhere? No. It says find the average rate of change of g prime of x on the interval -3 to 7. If it asks you to find an average rate of change, what are you doing? Okay, so it's kind of like mean value theorem. We're subtracting the endpoints, finding the slope between the endpoints, right? So we're doing this for g prime. And this says that the g prime is this graph. So that's another important thing. A lot of times people don't read the directions, so they don't know what the graph is, and then they misinterpret everything. So if we're finding the average rate of change here, we're taking the point at 7, we're taking the point at -3, and we're finding that average rate of change. So that's pretty straightforward. That's just finding a slope. And you get 1 point for that, just finding a slope. So doing Math 1 stuff, AP Calculus test, you get a point. Let's see, G double prime. Does the mean value theorem apply to the interval -3 to 7? Guarantee a value for C where G double prime is equal to this average rate of change. So why are they talking about G double prime? G double prime isn't in mean value theorem usually, right? What's in mean value theorem usually?
Just the first.
The first derivative and the original, right? So normally we would have g prime of c equals g of b minus g of a over b minus a. So the important takeaway from this is if I make g prime g double prime, what does that tell me about this side? It's going to be primes. All right? So what this is saying is this in mean value theorem would equal g double prime of c if mean value theorem applies, right? Because this is all g prime stuff, so this is taking it up a notch to do g double prime. All right, Maggie? What'd you say? I couldn't hear. Why is it g prime of 3 but not -3? That's a good question. It should be -3, should it not? Which would make this, let's see. Yeah, for the next part it doesn't matter, but let's see. That should be negative. I wouldn't have gotten credit for this because I wrote down all the wrong work. Ultimately, I got the same answer, but all my work is wrong, so I would have not gotten credit for. So this should be 5/10, which still equals 1/2. So wow, that's a strange thing to happen. Very coincidental. Thanks, Maggie. All right, so mean value theorem, a lot of people would look at this and say, yeah, sure, this is looking good. But if you keep looking a little bit harder, the function g prime is continuous, but it is not differentiable, and we talked about that before. And because of that, mean value does not apply. And so that's a little trick that sometimes comes up on these, so you got to look out for things like that. So no, and it says no with reason is your second point there. Soup. No with reason.